So, what is it? As I said all along, it's to help kind of recommend a solution, right? It's trying to kind of look at what your use cases are, put some requirements in, and we'll kind of guide you through the best practices to what we think the right solution is. And then we'll actually give you some sizing, right? What does this mean in hardware and software and stuff like that? It's kind of a rough estimate. It's only as good as the numbers you put in. So if you choose a different consolidation ratio, or if you put in the wrong hardware spec, or if you put in the wrong resource consumption from your users, then the figures you get out are going to be only as good as the figures you put in. So one of the reasons we called it an estimator. So it's not a design later. There's no magic button here. You're going to press it. It's going to spit out a design. You're going to sit in front of it with your boss and order the hardware and install it all. You could, but your sizing might be wrong. This is a tool to help you. You need to understand the design process to use it. The other thing I can't stress highly enough is you need to understand the assessment of your users. So if you decide you've got sales users you're going to integrate into a solution, how much resources, how many salespeople can I get on a particular hardware? Now, to do that, you need to understand how much CPU, how much memory, how much I/O that user generates. So you need to have assessed the user. You need to measure it in some way and put the data in here. So we'll show you how you can choose one of the standardized profiles, but that's a last option in our case. So to use the tool, we're going to go into, Chengbo's going to show us this in a minute, but we're going to go into a wizard-driven environment, and we've got 6 steps. Right? These are the input in blue. So we just go through it and we fill in the information. We go step 1 to 6. And we're going to get to step 7. This is our design decisions. Really recommendations based on all the input, all the requirements, all the stuff you've told us about, assessment data, hardware specs you're going to buy. Here's what we think you should do for those use cases. And then on 8, we're going to give you the results. So how much hardware and what location, and lots of information around about storage. So let's jump to demo.
Okay, please switch to this desktop screen.
Yep, I'll do it.
Ah, good, cool. The network was broken 1 minute ago, and it's recovered now, so God bless me. Let me refresh the page first. This is Horizon Sizing Estimator. I know you have understood that it's not an easy job to make a sizing for Horizon. Thanks, Graham. But now, it will be very easy to make an estimation with my tool. This tool is hosted on Internet Developer Center. You can access it from your mobile, from your iPad, from any device, if only you have an account. And we have 2 buttons here. I can new a profile by clicking this button. I can also list all profiles that I have saved. So this is a list. And I can delete a profile. If I want to share a profile with someone else, I can export it and import from someone else as the other account.
So this is very important. If you are working with a colleague, you kind of create this profile, and this is what I think is the answer. You can export this, send them a JSON file, they can import that, and they've got exactly as you had. It's also a great way of backing them up or copying them and stuff like that.
Yeah. So today I will edit a profile which I created in advance, VMware 2016. This is the first page. You have to input some basic information for your profile, like profile name, customer name, and the number of users. Office locations are where the users will use the Horizon client from. Data centers are where you host your infrastructure. User categories are names for your use cases. Here, let me add a new user category, which is Visual Designer.
So at this point, all we're really defining is where are my offices, where's my infrastructure, And you might use the categories that we talked about in the design process.
We click Next. In this part, we will define what is a view designer. We will define use cases. Let me expand view designer. We can select operating system, display. Core applications are applications for all use cases, not only for this one. But the departmental applications are for this use case only. We shall estimate the number of applications and the size on disk. Since this is a view designer, I will select high performance and 3D graphics together with graphic intensive applications. They may also need print to local printer as a view designer. Quite a lot of conditions here I can select, but let's go through them and click Next.
Okay. So hopefully you get the idea. We're just kind of marking off the requirements for this particular use case that we just added. You know, let me explain a few of them there. We've got, if we go back up to the applications, what we're actually doing there with core apps is these are apps that are used across multiple use cases. The reason we made it a selection box is we do hit scenarios where, yes, everyone gets Microsoft Office, but actually we've got factory workers that they don't get it. But my other 20 use cases do. So it's easier to do a core application stack and make it selectable. Departmental apps are kind of exactly what it sounds like. It's particular to this use case. And this triggers stuff like app volumes, app stacks. So in the minute you select that, it means we can then do a common pool, but we can use app stacks, a departmental app stack that kind of customizes this to this use case. And then the other one we've got there is user installed apps. That's going to do app volumes, writable volumes. You know, trigger that to that use case. Now we will try and keep this up to date. We'll tune the requirements as we go. So we kind of are always kind of enhancing the tool. You know, and we think there's a requirement that is needed to make a design decision. We try and drive it in here.
Now we go to the third step, workforce. In this step, we have to select the user category and input the number of users for this user category. Select office location and data center location. That's it. You can have multiple user categories for one data center. And click Next.
So just go back 1 minute, Shanbo, sorry.
Okay, workforce.
So really what we're doing here is we're stitching the bits together. You know, where are those users, my visual designers, which offices do they sit in, which data centers do they link to? And also, is there a concurrency? You know, maybe it's a shift work, so maybe it's 50% concurrency. Do they need external access? And again, that will have several impacts there. So if it's less than 100% concurrency, we'll calculate per concurrent user if it's a desktop. If it's external access, and we've said this type of user needs smart card, we'll drive in stuff like access points and maybe stuff like RSA, depending on what you've selected.
Step 4 is service quality. By default, the service class is silver. You can also select bronze, gold, which will affect your resource and your performance, high availability, and some others. You can select custom to define your own service class for each condition.
So the idea here is we're driving things like availability or performance primarily. So the silver is the default. I'd recommend you leave it on silver unless you want to kind of change the availability issue. The text will change as we change stuff here. And it'll kind of describe what the high setting is, what the gold setting is, and stuff like that. Silver kind of does an N+1. I think gold drives availability to N+2. Silver does kind of full memory reservation for desktops and a 100% memory reservation for RDSH and stuff like that. Again, the descriptions are in the text and you can change them. If you don't know what you're going to change it to, leave it at silver, leave it at the default.
Yeah. Here, I change the performance to high and click next.
So they can have a big impact on the number of hosts we need. If I drive the performance to high, we're going to do more reservations, we're going to do lower consolidation ratios, stuff like that. Again, we'll tell you in the text there.
Yeah, take an example for high performance host specification. You can specify your own CPU, memory for your EXSI hosts.
So again, what we're allowing you to do, there's really three possible outcomes here. One, we're going to give people a standardized desktop. Second one is we're going to give them a vGPU accelerated desktop. And thirdly, it could be an RDSH environment. So typically that's going to be three different sets of clusters, vSphere cluster to host it on. Definitely going to be three different types of VMs. So in a scaled environment, we tend to separate it out, which is what we do here. So what we've done here is define the hardware, right? What hardware are you going to build this on? You can tailor this. We'll show you in the results where we hit the limitations and where you can actually maybe go back and change figures here. The one interesting one we put in recently was the CPU architecture. This is to try and drive in a scaling factor, because not all CPU architectures are as performant as other ones. So you actually see the performance and the number of hosts go up and down as you go up and down the architecture scale. So there's a scaling of the performance. So.
For GPU selection at the bottom, is that number supposed to be discrete GPUs on, say, a card that has multiple individual units, like a K1 or K2 has 2 or 4 respectively GPUs?
So the question, I'll repeat for the room, is the number of GPU cards the number of GPU profiles on a card, or number of
discrete GPU units?
GPUs.
Those grid cards have multiple.
They have 2 or 4, yeah.
GPUs
Yeah.
Okay, so is it the number of GPU units on the card? No. It's the number of cards in the host.
Yeah, it's number of cards, and later you will see you can amend your card type. For example, we recommend K1, and you can use K2 if you like.
Yeah. And the other thing we allow you to do is in the design decisions or recommendations, we'll give a recommended profile. You can override that. So you can say, no, I don't want to use the M60, I want to use a different card. Now, we don't recommend the K1 and K2s, they're end of life. But we give that type of card and we give the profile. So one of the jobs we've got in the future is we need to go put the M10 in here, the new card. So.
Cool. We also give you option to use vSAN or not, traditional SAN or NFS. Let's click next.
So the storage can really have an impact on the sizing. So when we come to creating replicas, if I've got vSAN, I can create one replica. If I'm doing T storage, I can do that as well. But if I've got more traditional ones, we're doing stuff like instant clones, and I've got 10 data stores, we end up with a lot more objects and therefore a lot more space consumption. So that can have a big impact on the space sizing.
This is the last input for your profile, but this is the most important part, I think, assessment data. For View Designer, you can select predefined assessment data suggested by us, like task worker, office worker, knowledge worker, or power worker. But it's best if you can select a custom and use your own real assessment data for your user category, since that can be more accurate and help the sizing result.
So really what we're doing here is, for the visual designers, we're saying, how much compute, what's our average CPU utilization, memory utilization, I/O load on disk and stuff like that. So this is where we talked about, having to assess the actual consumption of that use case. And one of the things we've done here, as Xiangbo pointed out, is we've put predefined profiles in. Use them as your last resort. If you've not got any measurements, you've no idea, choose a profile that kind of matches. And we are going to try and put more descriptive titles in there, and maybe a bit of help there. But these follow kind of standardized terms. So Log and VSI have these, and they do a lot of their testing on knowledge worker, as this kind of standard. We've just done scaled ratios of that. You can go to custom. If you've done a measurement yourself, you can type them in. The other option, if you've gone to Lakeside and you've done a SysTrack, which they provide a free online version, I think you need to reach out to them, but they do a free online. You can actually export the file from their tool, import the XML file in here.
Okay, cool. So that's all for the input part. And by clicking next, we go to the result part. Result part contains two sections. The first is design decisions. Take an example. For VU Designer, we suggest VDI pool, we suggest BLAST, we suggest Windows 7 and linked clones. And the suggestions are calculated based on your previous input from step 1 to step 6. If you change your input, the suggestion will be also changed. So they are dynamic. However, you can amend. For example, you do not like the GPU M60, you can change it to K1 or K2. You can amend it by yourself. We also have some other suggestions like features, functions, components. We suggest app volumes. We suggest VIDM according to your requirement. You can remove them. You can add a new one. That's design decisions here.
So as you change stuff, we will try and make sure the logic is applied. So if you try and select something that's not possible, we'll try and pop up message and do that. We're also always changing the tool. So stuff like instant clones didn't support app volumes until 2.11. That came in only a couple of months ago. So we put those changes in as soon as we can to the tool to make sure that recommendations and what's possible, reflects the latest and greatest.
Okay, clicking next. This is the profile result. The result part, at the top, you can see profile summary. Some important data here. Number of data centers, total number of ESSI hosts. We get a number. And below, we have office location. For each office location, we calculated the bandwidth according to number of users and your requirement. For each data center, we calculated the hardware infrastructure, like the number of ESSI hosts for this data center. We have some different blocks here. Management block.
We'll just pause there. If you remember the block and pod I put up earlier, I said we take all the connection servers, security servers, access points, etc. We put them on separate hosts for performance issues. This is really what we're doing here, is we're detailing out, well, how many of each of those bits and pieces do I need to build in that management cluster?
Yeah. All different components and the number for each component are listed here. 3 desktop blocks here for the 3 different ESSI hosts that we specified in the infrastructure input. Desktop clusters, high performance clusters, and RDSH clusters. We list the number of ESSI hosts for each one. Here you can see how the hosts are calculated based by CPU, based by memory, based by VM per pCPU ratio.
So we looked at that. What we've done is we've actually, in this example, we've given you all 3 possible outcomes. We want to show you the 3 different types of clusters. But you could have 2 use cases that will only both use standardized desktops. So we'd see standardized desktops or maybe RDSH, or only one. So it'll depend on your outcome here. We've just shown 3 use cases that came to 3 different results. What we're doing here in the constraints part is trying to give you a bit of guidance in terms of your hardware selection. So if I looked at that there, well, my constraint, I need 25 hosts because I need 23 based on memory, and 2 based on my availability was actually set to gold, so n plus 2. So maybe my n plus 2 is too high, but also maybe my hosts don't have enough memory based on the consumption model and what I'm putting on it. So maybe I go back and I buy more memory for my hosts and go and change that. I go back to the infrastructure in step 5, change the server spec for my standardized desktops, add a bit more memory, come back and see if that's a bit more palatable. and it probably reduces the number of hosts down.
Yeah. For example, you find that CPU is memory is the bottleneck here. You need to increase your memory for each ESSi host to decrease the number of ESSi hosts. Then you can change your infrastructure and get a new result again here. Below, we have storage for each desktop cluster. We have our suggestion for you, storage like capacity and IOPS. And below, we have a storage summary, storage totals for all resources that you need.
So we're trying to give you a breakdown inside of each cluster. You know, how much space do we need, how much I/O do we need, and what type of I/O and what's using the space. You know, if it's instant clone pools, you know, how much of my replicas, my templates, my parents, how much are they taking up, and how much are my clones taking up? So we kind of give you the breakdown. We do that across the 3 possible cluster types, and then also as a summary, because most people will probably buy kind of standardized SANs, so they want the overall figure as well. So we'll give you the breakdown as much as possible so you understand the type of consumption.
Question. You should have a supported limitation of 140 VMs per line.
Yes.
Is that still applicable?
Okay, so the question is, we used to have a supported maximum of 140 VMs per LUN. Yes, that is still a limit, and it's even lower depending on what your storage is. So, VAI storage, does everyone know what VAI is? So it's basically integrated storage. Remember what the acronym stands for? But that's 140. If it's non-VAI, it's 128. If it's NFS, it's 250. If it's vSAN, it's 3,200. Mm-hmm. That's the supported maximums.
Where?
Right? Again, don't design to maximums, design to 80% of that. Unfortunately.
Yes.
Again,
And if you want to get a whole picture for your data center, here is a link. Generate architecture diagram. By clicking this link, you will get our suggested overall architecture diagram for you. This is calculated according to your requirement. If your profile is changed, this diagram is also changed. So this diagram is dynamically generated. You can drag and drop your component here. You can see clearly how many components are required and how many number of servers are required. This is data center, and this is DMZ zone. This is the user. Bandwidth is also listed here. We highlight some important network ports, but not complete.
So one of the approaches we took in somebody asked us, could you show all the ports? And it was like, well, that would be a busy diagram. So we kind of went, no. That's not the approach we took there. So we tried to show the ports from client to connectivity. So client connecting in maybe has to connect to a connection server, and then ultimately it's going to connect to an agent on a desktop or an RDSH. So what are the ports that we need there based on what we've selected? So again, if we've gone with the suggestion of BLAST and that's met the use case, we're going to show the ports for BLAST. Or if we switched one use case to PCRP, we'll show them. If you selected stuff like client drive redirection from an office, there's a separate TCP port for that, so we're going to show that. So we kind of dynamically show the ports that you need there. But it is just from a client perspective connecting in ultimately the connection server and to the agent.
You may want some other format other than the HTML format. Then we support a function export as PPT. Click this button, wait for a short while. It's downloading. You can get a PPT file for your profile. It contains all information for your profile. Let's go through it very quickly. Your title, your profile information, use case, and the requirement for each use case, workforce, and service quality, infrastructure, assessment data, design decision for each use case, profile summary, architecture, and storage. So everything that you input and output is included in this PPT.
So the idea here is, a lot of people go through this, they'll come up with, this is what I think I need to go forward with. I want to discuss it with my team or my management team, and put this through as a proposal. So we're tidying this up a little bit as we go. We've still kind of got a little bit of work to do on the PowerPoint, but we're trying to make it to the point where we can put the diagram in there as well, and you take that as an output and just sit down and discuss it. Sound good?
Yeah.
Cool.
Can you switch to the previous PPT slide?
Yep, I can do that.
Okay, cool.